Hey guys, in this video I'm going to run you through everything you need to know about circles and circle theorems for A-level maths. Every section is going to be timestamped so you can easily jump to a section or rewatch it if you need to. Hope you find this helpful. We need to know the equation for a circle in the xy plane. Let's work out the equation for a circle centered on the point AB. Our equation needs to restrict a general xy point in the plane such that it can only lie on the circle. For a point to lie on the circle, it needs to be a fixed distance away from the center. We call this the radius. We can draw a right-angled triangle and use Pythagoras' theorem to calculate the distance of a point from the center. The horizontal distance between these points would be x minus a, and the vertical distance would be y minus b. Applying Pythagoras' theorem now, we know a point xy must satisfy the equation x minus a squared plus y minus b squared equals the radius squared in order to lie on the circle. Let's consider the equation x minus 2 all squared plus y plus 3 all squared equals 49. Comparing this equation to the equation we worked out before, this would be a circle with center 2 minus 3 and a radius of 7. Sometimes we might have to work with an equation for a circle not in the form we saw before. For example, x squared plus y squared minus 4x plus 6y plus 3 equals 0 is still an equation for a circle, but in an expanded form. In order for us to know the center and the radius of this circle, we need to rewrite it in the form we saw earlier. To do this, let's start by writing the x terms and the y terms next to each other. Now, let's look at the x terms and complete the square. Next, let's look at the y terms and complete the square. Now let's substitute these new forms for the x and y terms into our equation. Next, we collect all the constant terms. Lastly, let's add 10 to both sides, and we get the standard form for a circle we saw earlier. Now we can see this is a circle with center 2 minus 3 and a radius equal to the square root of 10. Sorry for interrupting the video, guys, but if you need any extra help with maths, further maths, or physics, you might be interested in having some one-to-one lessons with me. I run all my lessons over Discord, and regular students are welcome to send me questions they have in their studies anytime. To find out more, head over to revisionsolutions.co.uk using the link in the description. Thanks for listening. Let's get back to the video. Let's look at our first circle theorem, which involves tangents. A tangent is a straight line that just touches a point on a curve but does not intersect at that point. If we draw a radius to a point where the tangent touches the curve, the radius will always be perpendicular to the tangent. Let's consider how this might be useful in a problem. If a radius to a point is always perpendicular to the tangent at that point, we know their gradients must be negative reciprocals of each other. If we use another point on the tangent, we can construct a right-angled triangle. This means we could use SOHCAHTOA or Pythagoras' theorem to calculate sides and angles for this triangle. Our second circle theorem is about perpendicular bisectors for chords in circles. A chord is a straight line that connects any 2 points on a circle. A perpendicular bisector is a straight line that cuts the chord at a right angle and splits it into 2 equal pieces. The circle theorem states that a perpendicular bisector to any chord will always be a diameter of the circle, meaning that it must also pass through the center of the circle. Let's think about how we can use this in calculations. We know the gradient of the diameter and the chord must be negative reciprocals of each other. We can construct another right-angled triangle if we draw a radius to one of the points on our chord. Our last circle theorem is about circumscribed triangles. A circumscribed triangle is a triangle where all three of the vertices lie on a single circle. Our circle theorem states that if one of the sides of our triangle is a diameter of the circle, the angle opposite the diameter will always be a right angle. This means the gradients of the two chords that form the right angle will always be negative reciprocals of each other, as well as our circumscribed triangle in this instance will always be a right angled triangle. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.